So now I'm using the project scheduling example to show how to apply the workload smoothing heuristics from the textbook. So now this is a problem from our lecture slides. So project scheduling with resource constraints. So we have the 14 activities defined. Actually, the activity 1 and the activity 14 are the dummy activities. So they actually do not exist, so that you can see the durations are 0 and resource usage also. So apart from the precedence relationships and the durations, and we also obtain the information or estimation about the resource use. So for example, here, if you have a capacity activity 2, so that means the activity 2 will use 7 units of resource and work 6 days. So that's the interpretation about the parameter or the data in this table. Now let's see how to actually find a feasible schedule for this problem. As we mentioned in the lecture video, actually this let me see this. Actually, the mathematical model is well defined, but the problem for the large network actually is rather difficult to be solved. So that's why we pursue the heuristic method. So let's see the solution or the problem setting in the Excel workbook. So you can download this Excel workbook from Blackboard. So in the column A to D, we actually have initial information about the project. So in this part, and then in order to use the word smoothing heuristics, we actually need to calculate the key values for the critical path method. So early start, late start, early finish, late finish, and float values. So this actually are the calculations you need to do based on the critical path method. So I probably should mention critical path method based calculations. And then after you got all these key values, we can move on to find the first, or we call it initial schedule. So where we can actually start to find the feasible solution. So here we call it the step 1. So in the row 21, step 1, we schedule the activities based on their earliest start time. So considering the precedence relationships, but we ignore the capacity constraints. So we know in this problem we have a resource capacity of 10 units of the resource. So that means per day maximum you can use 10 units of resource. So we just take the critical path schedule, ignoring the resource capacity constraints. Then we just schedule each activity based on their earliest start time. So you have all these key values here. So you just put the activities as a bar in the Excel table. So here I can show the activity 2. Activity 2, check on your critical path key value calculation. Activity 2 can start from the day 0 and lasts for 7 days. Now you can see I actually have, lasts for 6 days. Yeah, we use 7 units of resource and works for 6 days. So now you can see I have this from day 0 to day 5, 6 days work bar for activity 2. So the number on the bar 7 means you need 7 units of resource. Similarly, for activity 3, you can also start from the day 0 and activity 4, you can also start from day 0. So it's actually not a trivial work. You need to go back to check the earliest start time and the duration and the resource usage and put all this information together into this table. Make a schedule. So this is the first schedule you can start from. Obviously, this schedule is not feasible because we also calculate a total resource usage per day. Now you can see your capacity is 10, but for some of days, your capacity requirement actually is higher than 10. So obviously, this critical path-based schedule is not feasible. So next, then we need to actually work on improve this initial infeasible schedule into a feasible schedule. So we call it step 2. So level the resource consumption. So now you can see we start from the total resource violation activities. For example, in the first 3 days, we can see the schedule actually costs higher resource requirement than the capacity. So look at this schedule. The total requirement for resources is 13 units for first 3 days in order to tackle this conflict. So, or we call it resource overload. So I postpone the activity 2 for 3 days. Given the activity 2 actually is non-critical path, I also mark the slacks in this initial solution. So SK means that's a slack days. So for activity 2, I actually have a slack here. Here actually writing the float, so it's the same thing. So it's a slack is 7 days. So I have a large float to use. So definitely I move 3 days later for activity 2 and without changing the total project completion time, which is 17 days. So now you can see from day 0 to day 16. So I still use 16 days. And then I solved the capacity conflict in the first 3 days. So continuously, I can move the activities based on the capacity consumptions. So now after I reschedule the activity 2, you can see I still have the capacity conflict in the day from day 5 to day 9 in the 5 days. So I have to solve this problem. Then I look at the activities here. You can see in the day 5, I have a single day activity 5, which is critical activity, requires 6 units of resource. So if I postpone this activity until later time, of course, I can solve the resource conflicts. In this case, I have to move the activity 5 at least 4 days. Then this problem, resource conflict will be solved. But activity 5 is a critical path activity. So if I postpone activity 5, that means the entire project will be delayed, will be postponed or prolonged. So now I decided to move backward. So activity 5. Now you can see all the successor of activity 5 actually needs to be postponed. So now your activity 5 is moved to day 9, and then I can see here the activity activity 11. Let me see it. I cannot actually see it split too long. Activity 10, 12, and 13 actually on the critical path should also be moved backward. Now you can see actually all my projects now become 21 days. Previously, in the initial schedule, I need 17 days. Now I need 21 days. Of course, when you change all these schedules, you always need to check the network diagram and see now if you move backward activity 5 is in the critical path, then the activity 10, 12, 13, and 14 all need to be postponed because they're on the same path. So this is actually the second proposal. So I postponed activity 5, and the project completion time now is 21 days. And then now I check the capacity, the resource level. I found the day 6 and the day 7, the capacity, the resource conflict is still not solved. So I need to work on to postpone this activity. So now, if you look at the total consumption of the resource on the day 6, this is mainly caused by the activity 9. So the activity 9 use 8 units of resource, and the total requirement in day 6 is 18 now. If I just move back 1 day, so I move the activity 9 for 1 day, then I solve the day 6 problem. So, but if I move the activity 9 1 day, you actually can see the project completion time will not be changed. But in the day 10, I will have a trouble because 6 plus 8 will be 14. And continuously in the day 7, day 8, and the day 9, the capacity, the resource conflict actually is not solved. So I need to move more than 1 day. So in this case, I just directly move activity 9 to move activity 9 to day 13. So as you can see, I move activity 9 within a slack. So here you can see activity 9 actually have 7 days slack. So I can just move it for 4 days. Nothing will be changed. So okay, I have done that. In the third proposal, activity 9 is moved backward within the slack. So now I solve the resource conflict until day 12. So currently the project duration is still 21 days. However, from this day 13, day 14, and day 15, and even and also day 16, I have the resource conflict. I create a new resource conflict. So in this case, I need to further change the schedule. So the idea now is to actually move the activity 10 to later time. So of course here 6 plus 8 is 14. So if I just move 3 days, it won't solve the problem. So I needed to move backward at least 4 days. So I just move activity 12 and 13 for 4 days. Now I actually add an extra 4 days to my schedule. So now I need 25 days to complete this project. And then now I check the total resource usage per day, and you can see they satisfy now the capacity constraint for 10 days. So I solve the all the capacity conflicts. In other words, now I found a feasible solution. satisfy both the precedence constraints and the resource constraints. So if you go through these steps, and you will help you to understand what happened here. You just need to put all the information together. So early start time, floats or slacks, resource consumptions, and critical passes, critical activities. So do review that, and hopefully you can follow that.